But then again, no pain, no gain, and some of you don't want to go through the pain. But anyhow, all right. 5.4, solving quadratics by taking roots. Hey, just be careful this chapter. There's a lot involved. So we started off with multiplying polynomials. Secondly, then we factored. Why were we factoring? So we could do what we did last night, and that's solve quadratics by factoring. And remember, that's one of the three ways of solving a quadratic, right? Solving by factoring. The second in the list was solving by taking roots. That's what we're doing today. And the third in that list is solving by the quadratic equation. That's a couple days down the road. So we're going to do all three of those things this chapter. We're also going to get involved with imaginary numbers, which are complex numbers. We've got to do something called completing the square. We've got to even end up dealing with inequalities, which gives us, I know these are dirty words, conjunctions and disjunctions for solutions. So all of that is yet to come. So be careful this chapter. Review. Review, review, review. You need to do that. My time is limited at times, so be careful there. Review. All right. So when can you use roots to solve a quadratic? Because just like factoring is limited, and maybe you don't know that yet, the method we used yesterday is limited because guess what? Not every polynomial factors. So there's times when you can't solve a quadratic by factoring. Now, when you can, it's usually a good route to go. Nor can you always solve a quadratic by taking roots. This is actually the preferred route because it's the quickest route. This is the quickest way to solve a quadratic, by taking roots. The problem is you can't always take a root to solve a quadratic. It's got to be in the right condition. All right. So first off, this is the general form of a quadratic. This is something everybody should know. And this will come into play a lot more as we continue on in the chapter. The a is simply the multiplier of the squared term. The b is simply the multiplier of the coefficient of the x to the first power term, or the variable to the first power. And then the c is simply the number, the constant, when it's set equal to 0. So we'll see that a whole lot more. It's general form of a quadratic equation. Well, if you look to the right, now we have a quadratic equation in that general form. In this situation, in the box, I have the 3x, the positive 3x in the box. All right, so this is the term to the first power. When this is there, you cannot. So in this situation, you cannot or can't take the roots. You can't do it in that situation. So I know I'm giving you a negative example, but that's the way you figure it out. So answer, when can you use roots to solve a quadratic? Answer, when there is not an x to the first power term. When there is not an x to the first power term. Okay, and I say x, right? The variable could be n, like last night, r, or whatever, right? Whatever the variable is, you can't have the variable to the first power term. If you do, you can't take the root of both sides, except for one special case. And we'll deal with that later on at the end of the lesson. Okay. I can't tell you how important this next statement is, and I can't tell you how many times people will forget this. So I'm going to put stars around it. And if I could do neon flashing lights, I would do neon flashing lights. You know, I would do whatever I could to try to get you to remember this, and yet probably 4, 5, 6 of you are going to forget, and hence you're going to get these wrong, and you don't want to do that. But whenever you take the square root of both sides, what do you have to remember when you take that square root of the other side? Anybody remember? Back to Algebra 1? If you don't include this, you only have half the solutions. Don't forget the plus minus. Okay. Hence, see, you already had forgotten, but it was 2 years ago in Algebra 1. But you can't forget the plus minus, because if you do, you're only going to have one solution. And by the way, don't we already know that quadratics have 2 solutions? So look, if you're thinking and you're going to solve a quadratic by taking roots and you end up with one solution, you should say to yourself, what happened to the other solution? Oh yeah, I forgot the plus minus. But you can't forget the plus minus. It happens all the time. You can't. If you do, you only have half the solution, and half a solution is no solution at all. Sounds like a quote. Half a solution is no solution at all. All right. How do you solve taking roots? Isolate the square term. So that's different from what we did with solving by factoring, right? Solving by factoring, you set it equal to 0. Solving by taking roots, you don't set it equal to 0. You isolate the square term. Then you're ready to take the square root of both sides. And then simplify to finish it off. In the case of the special case, you'll see this later at the end. You got to split it into 2 equations to solve. But that's only with the special case. Okay, so basically what are we doing? We're going to isolate the square term. We're going to take the square root of both sides and finish it off. Right? Isolate the square term, take the square root of both sides, and finish it off. All right, so let's look at a couple examples. So you got example A. We want to isolate the square term. So hopefully you agree. Let's add a positive 2 to both sides. And we end up at x squared equals 44, right? I added a positive 2 to both sides. Okay, I've got the square term isolated. I'm now ready to take the square root of both sides. And is that what you would do? Just like that? Sound good? How many like that? What am I missing? Don't forget the plus minus. All right, I always write it in as soon as I take the square root of both sides, because if you forget it, you're going to have the wrong answer. Okay, square roots undo squares, so the left is x. And we've got a radical for an answer in this one. Now, sometimes you'll be taking like the square root of 36. Great. What would the answer be? Plus or minus 6, right? Maybe you got the square root of 49. Great. What's the answer? Plus minus 7. Maybe you got the square root of 144. Great. Answer. Plus or minus 12, right? In this case, we have a radical. We don't want round-off answers, so we don't want you to punch into your calculator. But do we all remember how to simplify radicals? Right? This is a 4 times 11. Right? A 44 is a 4 times 11. I chose 4 because can we take the square root of 4? Yeah. We all know the square root of 4 is 2. And that 11 stays in the radical, right? So we get plus or minus 2 times the square root of 11. And again, we're showing both answers in one, right? One answer is 2 times the square root of 11. The other answer is negative 2 times the square root of 11. Okay? And that's the solution. So second scenario, similar. We got to move to 27. I'm going to use blue. I like blue better. So now we're going to add a positive 27 to both sides. You're going to move to 3, right? So we're going to divide that other side by 3. So where are we at right now? X squared equals, by the way, if you notice, I'm always leaving some space when I do this. Right? I'm at x squared equals 9, so I don't have to do another step. In this one, we're now ready to take square root of both sides. Don't forget the plus minus. And this thing ends up x equals plus or minus 3, right? And away we go. You could solve that one by factoring. The other one, if you're creative, by factoring. if you're creative, but this is quicker. All right. Any questions so far, anybody? Waste my breath. All right. C. So you look at C, and C looks a little bit convoluted. And I noticed one thing right off the bat with C. Wait a minute. I've got an a to the first power term. I thought we're not supposed to be able to take the square root of both sides if we have the variable to the first power. And in a normal scenario, the answer would be, yeah, we can't. However, there's a positive 7a on the other side, isn't there? And whether the other side equals or adds up to positive 7a or whatever, in reality, if you were to move either one, they would add out, right? Whenever you have the same quantity on both sides of an equal sign, they're gone. So in actuality, this one can be solved by taking the square root of both sides. Agreed? You with me? You got life out there? Okay. So now what's it all about? Isolating the squared term. Go ahead and take the square root and solve. So why don't you guys work on this one? I'm going to pause the video. So we got a equals plus or minus the square root of 7. Agreed? Right. So we're just isolating the squared term. Once we get it isolated, take the square root of both sides. How do we isolate it? The way we isolate everything. Things added to the variable move by the opposite to both sides. Things multiplied times the variable move by multiplying both sides by the reciprocal. All right, so hopefully plus or minus square root of 7. Just leave it like that. It's an exact answer. That's what we want. All right, D is unique to what we've done so far in that the way you finish it off. So we're going to move the negative 3, and hopefully you agree we're there. We're going to divide both sides by the 9, and hopefully you agree we're there. So this next step then looks like this. When we take the square root of both sides, we have the square root of 8/9. Not a big deal, right? Because we all remember the rule that this is the square root of 8 over the square root of 9, right? It's the square root of the numerator divided by the square root of the denominator. Some might say, how come you don't do the plus minus on the top and on the bottom? You would be, in effect, canceling them out. You do it to either the top or the bottom. Again, we always do it to the top. So the top will take care of it. Are we done? No, because we can simplify both the square root of 8 and the square root of 9. So hopefully you agree the square root of 8 is 2 times the square root of 2. Because what is an 8? 2 times 4. What's the square root of 4? 2, right? 2 comes out, a 2's left in, and we all know the square root of 9 is 3. So you end up with plus or minus 2 times the square root of 2 over 3. So one root is 2 times square root of 2 over 3. The other root, negative 2 times square root of 2 over 3. Fair enough? Okay, so that then causes me to remind you guys of the aspect of rationalizing the denominator. So to rationalize the denominator. Look, the example I just did, I'm able to take the square root of the denominator, right? Square root of 9 is 3. Good. Don't have to worry about it. But if you remember, we're not supposed to leave radicals in the denominator. And the way to take care of them is to rationalize the denominator. So again, if you were solving a quadratic and you have a root in the denominator, you're going to have to rationalize the denominator to finish, right? So just a quick refresher. So what would I do to 1 over square root of 5? Somebody raise their hand and tell me what to do. What do I do? Luke? All right, so we're worried about the bottom. Luke says if I multiply the bottom by the square root of 5, I now have the square root of 25 on the bottom, and I can take the square root. And whatever you do at the bottom, of course, you're going to do the same thing at the top because you're multiplying by a form of 1, and this thing ends up with the square root of 5 over 5. The square root of 5 times the square root of 5 is a 5. Okay, so B, similar situation. Remember, your focus is the denominator. That's where your issue is. I could really do a little simplifying here. Half of you right now close your eyes. The other half, you can look. Look, I know that if I put these two together, I can reduce the 2 over 6 and make this a 1 over 3, right? So those of you that can handle that, you can start that way. It makes it a little quicker. All right, others of you, you don't see that, you don't understand that, fine. Treat it like a square root of 6. Am I worried about that 2 times it? No, I'm worried about the radical. Multiply the bottom by a square root of 6. Whatever you do at the bottom, do the same thing at the top. Square root of 6. Let's look where we're at. The top is a 9 times the square root of 2 times 6. I wrote it that way on purpose. I'll show you why in a minute. The bottom, you still have the 2, right? And square root of 6 times square root of 6 is a 6. So that's where you'd be at right now. Okay, why did I write the top that way? Because look, here's this 6 is a 2 times 3, right? And can't you take the square root of a 2 times 2? Yeah. Square root of a 4 is a 2, and now I get a 2 out. So now I got to finish this thing off by reducing. How about that 2 and that 2? How about making this 6 a 2 times a 3? How about making the 9 a 3 times a 3? And now those 3's go. Okay, so what did I just do? I made the 6 on the bottom a 2 times 3. The 9 on the top a 3 times 3. Those 3's divide out. What's left? I got a 3 times the square root of 3 on the top, and what, a 2 on the bottom? Now again, that one had a lot of simplifying. So I'm trying to refresh your memory on something that might come up that's about as tough as you'll get those right now. Because it's just simplifying. Rationalizing the denominator. So sometimes when you solve by taking the square root of both sides, you're going to have to rationalize the denominator, and you just got to be aware of it. You got to be looking for it. You got to be ready for it. Okay, so here's a scenario like that. So I'm going to move the 60. I'm going to divide by 9. Actually, this thing, you don't even have to rationalize the denominator, so you take square root of both sides, and away you go. All right, so square root there, plus minus. So the top, hopefully you agree, is plus or minus square root of 60. We'll deal with that in a minute. Bottom, we all know square root of 9 is 3. And just simplify the 60. So let's see, I'm looking for 4s or 9s, right? What is 60? 4 times 15? And what's the square root of 4? 2. So plus or minus 2 times the square root of 15 over 3. All right, not the best example. I meant to have a bottom where we had to rationalize, but I didn't need to. Such is life. Okay. I needed to go a little fast there because I got to get to the aspect of imaginary numbers. We're only going to mention a couple quick facts about imaginary numbers. We will deal with them a little bit more fully a couple lessons from now. So I'm just introducing them now and giving you a couple quick facts about them. What are they basically? An even root of a negative radicand. An imaginary number is an even root of a negative radicand. And I is the designation for an imaginary number. And what does I equal? The square root of negative 1. find a real number that is the square root of negative 1. It doesn't exist. Because 1 times 1 isn't a negative 1. Doesn't give you negative 1 in the denominator. And a negative 1 times a negative 1 gives you a positive 1. Doesn't give you a negative 1 either. How can you multiply two things together and get a negative? That are the two things that are the same and get a negative? You can't, right? Because a positive times a positive is a positive. Two positive numbers that are the same. Negative times a negative, two negative numbers that are the same are going to give you a positive. You can never end up at a negative. Well, we have a way to deal with that. It's called imaginary numbers. And we'll make the square root of negative 1 I, an imaginary number. All right, so that's the key concept. Look what happens with I squared. I squared's kind of neat. It's an imaginary number, right? But what is the square root of negative 1 times the square root of negative 1? Is a negative 1. Ah, we went from imaginary to real. We're back into the world of the real. And it is a real solution. So if you ever square I, you're back to a real number. Negative 1. Awesome. All right, again, I'm going to develop those two facts more fully a couple lessons from now. And we'll talk more fully about imaginary numbers. You just need to be aware when you end up with a square root of a negative number. So look at B there, right? Square root of negative 4. Again, you can't find two things times itself to give you a negative 4. However, we could treat it like this. What if we say the square root of negative, here, let me do it this way. What if we say the square root of negative 4 is really the square root of 4 times a negative 1? Do you agree that's still the square root of negative 4? Right? Square root of 4 times a negative 1. Now what if I split that up into the square root of 4 times the square root of negative 1? Because technically that's what we did whenever we simplified anything. But just real quick, just watch for 1 second. If I had a square root of 28, technically it's a 4 times 7. And technically, it's a square root of 4 times the square root of 7. And what's the square root of 4? 2. And that's how we simplified it, right? So that's all we're doing here. That's all we're doing here. So watch. We all know the square root of 4 is 2. And we also now know that the square root of negative 1 is I. And what do you end up with? 2I. You end up with 2I. What about like a negative 20? Well, this is just like a 4 times a 5 times a negative 1, right? What's the square root of 4? 2. What's the square root of negative 1? I. And what's left in? The square root of 5. See, it's what we've done already with simplifying. The only other thing you got to add is the I for the negative. That's all you're doing. Whenever it's a negative radicand, include the I for the negative. Everything else simplifies just the way we've done them. Just the way we've done them. Okay, my time's getting away, so got to be careful here. Look, this is, your book's big on properties. This thing makes a whole lot more sense in just the practical use of it than it does in what we're going to write. But just hang in there. All right, the first situation is, what if k is greater than 0? What do we simply mean? It's positive. Now look, here's what we're talking about in all this. We're talking about k is the radicand. What if you have a positive radicand? Okay, the radicand is positive. Well, we're going to tell you you're going to have two real number solutions. We've done a bunch of quadratics like that. And technically the solution is plus or minus the square root of k. That's what we just did. What if k equals 0? Remember the homework problem? Some of you guys asked me, do I write x equal negative 9, x equal negative 9? Do I write it twice? And I said, no, it's the same value. Well, that's this situation. When it ends up equaling 0, then you're going to have one real solution. It's the same answer twice. We only write it once. Okay? the same answer once. We only write it once. And x equals 0. I don't know if I like that answer. I think that should be x equals k. Whoops, lost my shade. Come back. I'm going to put k there, though I don't want to stop and think because my time is very limited. Okay, what's the third scenario? When k is less than 0, meaning it's negative. So again, think for a second. This is a negative radicand. Isn't that what we just did? A negative radicand, and we said that's an imaginary number. Imaginary numbers are also called complex numbers, and there are two complex solutions. Now again, I wouldn't get caught up with the plus minus I times the square root of the absolute value of k. All right. That's technically how it ends up, plus or minus I times the square root of the absolute value of k. I wouldn't take my time memorizing that, because you know what? If you just know how to solve the thing, you'll end up there. That's where you'll end up. So, you know, in our day and age, they got to give you formulas for everything. Look, don't worry about it. Just solve it. You'll end up there. So let's solve one. So here's the situation. Let's add a negative 24 to both sides. Let's divide both sides by 3. Are you with me? Right? We moved the 24. We moved the 3. I'm now at t squared equals what? Negative 8. Am I now ready to take the square root of both sides? Okay, by the way, what category are we in? We're in the third category. But who cares? I'm just going to solve the equation. I'll get that answer, right? Take square root of both sides. All right, somebody raise your hand and tell me what to write for a final answer. What would be our final answer? She got a square root of negative 8. Julia? Ooh, just a little itty bitty bit off. What are you forgetting? Yeah, don't forget the plus minus. All right. Right? Plus or minus 2i times the square root of 2. So again, for those of you that don't understand, off to the side, this is a negative 1 times a 2 times 4. What's the square root of 4? That's the 2. What's the square root of negative 1? That's the I. And what's left in, that's square root of 2, right? 2i times square root of 2. All right. So look, where do we end up? There, but we just did it with the math, and it's a whole lot easier. All right. I got time for 2 special cases. Awesome. Isn't Algebra 2 awesome? We just learned so little in here. I don't know why anybody would ever think that you need to study. I mean, we hardly get to anything. We hardly learn anything. No new concepts ever come up. It's like one every 3 weeks or something, you know. I mean, studying. Who would ever need to study to remember this stuff? I'm sure we all have great brains. We just remember it all at a piece. And it's only one thing here or there. So, I mean, no big deal. All right, special form. If you were to multiply this out, you would actually have an x to the first power term. But because it's in this form, we don't have to worry about it. The actuality is the quantity with the variable is isolated. And we're actually ready right now to take the square root of both sides. Don't forget the plus minus. So now the next line would be x minus 2, because square roots undo squares, equals plus or minus 2. Agreed? The only problem is we're not completely done yet. We have to finish this one. We have to one time use the plus sign of we have to use the positive 2, and we have to do a second equation using the negative 2. We got to split it up to get the 2 solutions. And just like any equation, we got to move the negative 2 from the left to the right, right? So in the first case, when you add a positive 2 to both sides, you get 4. In the second case, when you add a positive 2 to both sides, you get a 0, right? And there's the solution. X equals 4, x equals 0. Well, we're expecting 2 solutions. What do we get? 2 solutions. Cool. Second scenario. Hey, I got a multiplier. I got to move that first, right? I got to isolate the squared quantity. right? See how we're doing the same things over and over again? Isolate the squared term, isolate the squared quantity. Now, Matt, and let's, for space sake, would you agree that's a 25, right? And now we're ready to take square root of both sides. Don't forget the plus minus. So what am I at? X plus 5 equals plus or minus. Oh, why did I use a 5? I got to get 0 again. You don't always get 0. All right, should have picked like a 3 or a 1 or whatever. Duh. All right, so again, you got to split it up. X plus 5 equals plus 5. X plus 5 equals minus 5. It's because of that plus minus. We're doing the two possibilities. So the first one this time gives you 0. Why did I use 5? And the second one gives you negative 10. Okay, I should have hustled in my last example. Hey, just watch this one. Don't write unless you're a quick writer. Hopefully you agree that's a negative 9. Square root of both sides, plus or minus. X minus 4 equals plus or minus 3i. Yes? All right, so watch how you finish. X minus 4 equals 3i. X minus 4 equals negative 3i. Proper form is to put the regular number in front. So this is 4 plus 3i. And this is 4 minus 3i. By the way, what kind of things are these? Think English. A 4 plus 3i and a 4 minus 3i. If they were quantities, we would call them a difference of two squares, and they're also conjugates. Awesome. Who said that? Awesome. They're conjugates. You always get conjugates for imaginary numbers and quadratics. Cool. All right, I know that was fast. Hey, if I went too fast, watch the video on HCS Math class, because I did make the video.